Good morning, everyone.
Right.
There are nine. There are 8 students now. So check your learning. To be 32 students. Just wait for a few minutes for the other students to come in. Okay, good morning. Okay, we'll while letting the other students come in, we will just go through our class. I will share my screen. Okay. Today we'll cover topic on actually topic 4, 5, and 6. We'll cover how how much we can cover by today, and then I have uploaded into your WhatsApp the notes. Okay. We talk about IT infrastructure. So what is IT infrastructure? Okay, it is the shared technology resources that provide platform for the firm specific information system application. So we look at in developing the information systems application. So what are the platform required, and then the technology shared technology resources are referred to as the IT infrastructure. So the IT infrastructure is the shared technology resources that provide the platform for the firm's specific information system applications. So it comprises of several things, including the set of physical devices, software, the networking, and others. So this firm wide services include the computing platform, including the computing services, physical facilities, IT management, and so on. We refer to them as service platform. We look at it from service platform perspective, meaning that whatever we do, we look at the value of investment, the accurate value of investment. So how do we develop our IT services and infrastructure? Yeah, so before we can come up with our IT services and infrastructure, okay, we were, of course, in any businesses, they will start with a business strategy first. Yeah, we'll start with the business strategy. Yes. Okay, we will start with the business strategy. The business strategy is developed by the top level management. So it decides what to do, whether to invest into new businesses, and then the direction of the organization. So it's being determined at the top level management in this business strategy. It's usually not a short-term goal, but rather a long-term goal, the business strategy. And then within the business strategy, we have this what we call IT strategy. IT strategy is similar like other, not similar, at the same rank of other strategy like marketing strategy, financial strategy, production strategy, and then we have IT strategy. So IT strategy is more functional. Yeah. So what it does, how does IT serve its purpose to meet to the business strategy? So this IT strategy will derive from this business strategy. Yeah, and then it's also support the business strategy. Okay, and then with this IT strategy, we will also look out in the technologies that they are in the market. What are the technologies available in the market, and then we determine which of those that are suitable for to meet our IT strategy and our business strategy. So we look at that whether this fit into our business strategy, and then how does it fit with our IT strategy. Yeah. Then from this business strategy, IT strategy, and the information technology available outside there in the marketplace, we determine our IT services and infrastructure. Remember, the goal of IT services infrastructure is to cater for the customer services, to cater for the supplier services, and the enterprise services for your We call it for your business processes. So you will provide customer service, it will provide supplier service, and will also cater for the business processes. Yeah. So how do we develop this IT services is by getting information uh, from the business strategy, from IT strategy, and information technology. Yeah. So based on the business strategy, IT strategy, and information technology, we will develop our IT services and infrastructure. The goal of this IT services and infrastructure is to support the business services and the customer services, support the supplier services, how we deal with our vendors, and then also the enterprise services, how we attend to our business processes. So this IT infrastructure provides the foundation for serving customers, working with vendors, and managing internal business processes. Okay. Any questions so far? This is everybody okay? Yeah. So what are the services that being provided by the IT infrastructure? The first one is computing platform. Computing platform provide computing services that connect employees, customers, suppliers into a coherent digital environment. So this computing platform will comprise of hardware, comprise of software, comprise of networking and other utilities in order to provide these computing services to connect these employees, customers, and suppliers into an environment, coherent digital environment. So, in order to provide these services, computing services, to have this computing platform, we will require a telecommunication services. Telecommunication services combine data, voice, and video connectivity. Yeah. So we have data, we have voice, uh, the telephony, and also video connectivity, yeah, using telecommunication services. And then we will also have data management services that store and manage the corporate data and provide capability for analyzing the data. We will have our database management system. And then on top of this is the basic infrastructure, computing platform, telecommunication services, and data management services are the basic infrastructure. On top of it, we will also have application software services, especially for businesses. So we have ERP, enterprise resource planning system. We have CRM. We have SEM, yeah, supply chain management and knowledge management system. So combination of these, we need physical facilities to develop and manage the physical installation required for the computing, telecommunication, and data management services. Okay, besides that, other ancillary systems that we need is IT management services to plan and develop the IT infrastructure, coordinate with the business units, manage the accounting for the IT infrastructure expenditure, and then provide project management services. Then we maintain IT standards. We will discuss IT standards specifically later. So this IT standard will provide the firm and its business unit with policies to determine which IT, which technology will be used, when and how. IT education services that provides training to the employees, and IT R&D, research and development services that provide the firm with research on future IT projects and what sort of investment that firm will require to differentiate itself in the marketplace. So these are the five and four, nine services provided by IT infrastructure: computing platform, telecommunication services, data management services, application software services, facilities management services, IT management services, IT standard services, IT education services, and IT research and development services. Okay. Any questions so far on these services? Everybody can follow? Okay, so we will look into the stages of evolution for the IT infrastructure, stages of in IT infrastructure evolution, mainframe computer, personal computer, client server. But before that, uh, the first computers are mechanical computers. Have you heard of mechanical computers? Have you ever heard of mechanical computers? Okay, I want to share a video.
Charles Babbage was the only child of a tyrannical London banker, a bully at home. But his money kept his son and heir financially comfortable for life. Cambridge educated in mathematics and supremely self-possessed, Charles became an iconoclastic writer and habitual inventor. In 1832, the drawing room of his London home became a showcase for demonstrations of a small section of his difference engine, a far from finished device by which he intended to revolutionize calculation by mechanizing it. At his soirees, London's intellectual society watched what you see now. As Babbage cranked its handle, this machine produced a series of polynomial calculations that were repeatable and error-free. Most astonishing, it was automatic. Any of his illustrious guests might have operated the handle as well as Charles Babbage, perhaps the geologist Charles Lyell, or Charles Darwin, or Charles Dickens. Once set, the machine seemed able to proceed, to think, on its own. But what was called the beautiful fragment of the machine Babbage had intended to build was all he ever finished of it. In fact, his imagination had already moved on to an even more ambitious mechanism, one that would make obsolete the abandoned machine. The analytical engine would be a general-purpose calculating automaton. For most of 30 years, he would revise and improve his notional design. Only a few partial sections of it were built, this one after Babbage's death by his son. The analytical engine was an ever-evolving machine. Each breakthrough elegantly drawn up, annotated to describe mechanical motions with a coding system that Babbage claimed was his finest invention. The analytical engine may be the most intricate operating mechanism ever fully realized with paper and imagination alone. In 1846, Babbage abruptly changed course. As if determined to make good on an old obligation, he worked for 2 years to complete a full set of drawings for difference engine number 2. It would require 8,000 parts, only a third as many as the first. He offered it to the government, but did not protest when it declined to build it, and the drawings were carefully put away. Eventually, they came from the Babbage estate to rest in the library of the Science Museum in London. More than 130 years later, in 1985, the museum's new curator of computing, Doran Swade, became convinced the institution could build Difference Engine number 2. After all, with the intact drawings, it seemed feasible and within financial reach. It took 17 years and drama to rival Babbage's so long ago. And it works, just as Babbage designed it. Every turn of the engine's driving handle is carried through gears, cams, rods, levers, and springs to release and arrest precisely aligned number wheels. A helical arrangement of steel fingers continually pulls the register towers to find and perform the carrying of tens. In its continuing sweep upward, it is mesmerizing. The intricate printing section can be programmed for 1, 2, or 3 column output, for 2 font sizes at once, for variable margins and column gaps, even word wrap where necessary. It prints hard copy on paper and simultaneously impresses the same output into a tray of plaster to produce a stereotype, a mold for casting a full-page printing plate. When a tray is full, the printer pauses the entire machine. In the spring of 2008, a clone of DE2 commissioned by Nathan Myhrvold was completed at the Science Museum and shipped to California. At the Computer History Museum, it would charm new thousands of discerning eyes. Today, the crotchety proud genius, who never managed to prove it during his lifetime, has a fair claim to honor as a pioneer in the history of intelligent machines, just as his parlor guests in 1832 suggested. His Difference Engine continues to inspire the admiration of his intellectual heirs, a celebrated and unique icon to chroniclers of computing. Charles Babbage, remember, never saw it, except in his stubborn, prescient dreams.
Okay, those who have studied computer science would have read about Babbage and Ida Lovelace and his machines. Like the computers, the early computers, it was mechanical. Yeah, risky. And then it removes electrical and becomes electronic. I want to share also is the first video on the first electronic computers. Share my screen again.
Juggling. This is called misdirection.
At the Moore School of Electrical Engineering at the University of Pennsylvania, they were very, very strong in computation because there were engineers back then who were moving more toward not just how you do things based on what people did before, but to break new frontiers. And as they did that, the mathematical complications became difficult to solve. So they needed a machine. So they decided electrons are faster, we'll move them through these tubes, and we'll click them on and off, and we'll make a machine that would solve these equations. They created the world's first all-electronic, general-purpose digital computer. When the war started, they were picked especially to do computations for the Army for long guns and firing tables.
ENIAC was revolutionary in being the first large-scale general-purpose electronic digital computer ever built, and led to the evolution towards modern computer technology by developing the stored program architecture that is the fundamental architecture for all computers today.
They solved these equations that they thought would take 2 years in 2 hours. They did it. So the world changed.
You know, without ENIAC and the University of Pennsylvania and the city of Philadelphia, we wouldn't have Google, we wouldn't have Microsoft, we wouldn't have, you know, the things that are driving today's economy and the rapid innovation that keep happening in computer devices.
People just create things even if they're not being prompted to. That's what human beings are about.
You need new knowledge to start something new in the marketplace. So people create knowledge. Knowledge is inherently human.
Prof, you're on mute.
Okay, after this advent of computers, we move into mainframe. Mainframe was from 1959 until present. And then we have personal computers in 1981 until present, and then we have client servers computers. So mainframe, there are still mainframe being used today, especially in the banking and telecommunication sector. Mainframe are large computers and then connected to terminals. We call it dumb terminals. They are connected to dumb terminals, or sometimes we also call it as what do you call it, thin clients. Yeah, so they're connected from, this is the mainframe connected to the dumb terminals and thin clients. And then, but mainframes are very huge and very expensive. And then in I think late 1970s, with the advent of personal computers popularized by Steve Jobs, and then there are more and more personal computers being sold. And then 1981 and until the present, people are using personal computers. And then with these personal computers come the client server. Client server connects the server with the clients. Clients can be a personal computer or a dumb terminal as used in the mainframe, or a thin clients. Yeah, thin clients or a dumb terminal. Or it can also be a PC. Okay. Then this is an example of the client server era, 1983 to present, where we have this client, which can be a thin client or dumb terminal or a PC connected to the internet, and then the internet connected to the web server. Before this, before the web server, we have in the middle, we have this, what do you have there in the middle? Before we reach the web server, anybody? Risky, what do we have here? Between web server and
DNS.
oh, we have a DNS. We have a DNS. Domain name server. Then only we have the web server and application server. And then from the application server connected to the each departments, and then we have data network here. This is the client server era. Yeah. Then after that, we have this enterprise computing, 1992 onwards, where we are connected to the internet. We have an enterprise server connected to some other servers, and then connected to the PCs. Today, we have cloud computing. cloud computing, we have the cloud, which are actually the same servers here. We develop here, and then they share resources. It can be infrastructure resources, software resources. Yeah, they share resources so that other systems are able to use it. The term is pay per use. Usually, it's pay per use. Yeah. Okay. So this is the evolution of computers. So what mentioned by Gordon Moore, actually there is some error here because he did not mention all these things. Some of these things are written because in the open learning I put up the actual article that he has written, and then there are later authors that came up with this, that microprocessor doubles every 18 months, and then computing power doubles every 18 months, and price of computing falls by half every 18 months. So this is purportedly said by uh, Gordon Moore, but I included in the open learning the actual article, so it didn't say all these things, but it is purported by somebody else. So you can see that anyway, you can see that the MIPS millions instruction processing have increased. Yeah, the MIPS power, the processing power have increased over time from 1970 to 2016. The number of transistors have increased, and then the price of the transistor also have reduced, and then there are the 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 transistors are now replaced by uh, using atoms, using nanotechnology. We are reducing the chips, and then the storage price is also being cheaper and cheaper. So the amount of data being stored for each year doubles because due to the reduction in cost of storage. Now, even you can have a tera in a USB drive, and then the technology drivers in terms of the connectivity also have increased. The formula for this connectivity is, this is the formula for the connectivity, and then you can see the increment due to the advent of the internet. Yeah. So value of power of network grows exponentially when the number of network members increase, and then uh, so so this is where we see the internet. So due to this, and then of course there is declining telecommunication costs and internet. If I can recall, during the first internet came to Malaysia, it cost about 2.5 cents per minute. Yeah, so every time you use internet, you count the time that you use the internet because you will cost about 2.5 cents per minute. So with the reduction of the communication cost, it occurs the exponential growth in size of the internet. When I need to check, okay, this recording. Okay, and then there are also standards and networks that being developed over time to cater to the development of the information technology. Standards such as we have some standards here, such as ASCII. ASCII is the American Standard Code for Information Interchange. It regulates the alphabets and the numbers that we use, how it is converted into machine language, and then the common business-oriented language is being used, which are being used by the banking sector and another commercial sector. COBOL, Unix from 1969. Today, from Unix we have Mac iOS. We have from Mac we have iOS, and then from Unix also we have Linux. From Linux we have today's Android. Yeah, and then so these are the evolution of the operating system. Yeah, operating system. To the whiteboard. Okay, so we have Unix. Unix is an operating system. From Unix, we have what? We have Mac OS today, and then we have iOS, and then from Unix also we have Linux. From Linux, what we have? We have Red Hat, we have Ubuntu, we have Debian, and then most prominent we have Android here, and then we have other, like for example like PBS, which is being used by a lot of networking devices, and then there are now. So you can see that from the standard created by Unix, we have Mac, we have iOS being used today, and then we have Linux. From Linux, we have Android. Android is part of Linux, and then we have PBS, and then many more. Before the Unix, before the advent of Linux, and even especially from MS-DOS, MS-DOS, and then we have here Win95. Until today, we have Win95, and then they have WinNT, and then from the WinNT, and then today we have Windows 10, Windows 7, Windows 10, and so on. So before this period, every computer producers develop their own operating system. So after this, later with the advent with the standardization of Unix, so every computer producers do not have to develop their own operating system, but they can just use what the open standards that there are. Yeah, so we have this Unix. We have the TCP/IP, Transmission Control Protocol, Internet Protocol. We'll discuss more about this in the networking. It's just the standard being used for the Internet. Ethernet is the standard used for networking. And then we have IBM, Microsoft, Intel personal computer within advent of Microsoft DOS, MS-DOS, Microsoft DOS, and then where the Bill Gates offers Microsoft DOS to be used in IBM systems. So there is a standardization, and then the first compatible IBM compatible computer, or we call it clone IBM clones, or it's compact computer now acquired by HP. Yeah, HP Compact now no longer Compact. They call it HP. World Wide Web developed many standards actually. XML, HTML are developed by World Wide Web. Yeah. There are also other standards that we will look into later one by one. What else? Transmission protocol. Is there any other standards that you know that you want to share? Any other standards that you know that you want to share? Maybe we have standards that are being used by IoT, standards that are being used by big data. Yeah, so there are standards, many standards that are being used. Okay. Components of IT infrastructure. IT infrastructure comprise of these 7 main components: the hardware platform, the operating system, the enterprise software application, data management and storage, networking and telecommunication platform, internet platform. Yeah. Internet platform, enterprise software application, data management and storage, networking, covers internet, and then internet platform, and then also consulting system integration services. We'll move one by one. So look at it one by one. Here is the computing hardware. We have hardware like Dell, IBM, Sun, HP, Apple, and then we have operating systems. The most prominent are Microsoft Windows, Linux, Unix, Mac OS, Chrome, Android, iOS, and then we have application software, enterprise software applications, including their middleware, SAP, Oracle, yeah, Oracle, Microsoft, IBM, and networking telecommunication systems like Linux, Cisco, AT&T, Verizon, and then we have internet platform, yeah, IIS, Net, Apache, Unix, Cisco, Java, and then data management software. Yeah, we have Sybase, MySQL, MS Oracle, Hadoop meant for big data, and then we also have consultant and system integrators. These are the hardware. There are two groups of hardware. This is the client machines. Client machines, we have the desktop, PCs, laptop, mobile computing. We have tablets. Just each desktop chips and mobile chips are different. And then these are the servers. We have this rack server. This is tower server. And then we have a blade server that you put in blades. And then these are the mainframe. These still have not disappeared, still being used in, especially in the banking and telecommunications network. And then on top of, and then this hardware could not run without an operating system. The operating system runs, we have drivers to run the hardware. So most prominent are these Linux, we have Ubuntu here, Unix, Red Hat, Mac, Google Chrome. We have OS at the corporate server, Windows Server, Linux, and Unix, and then at the client level, we have Android, iOS, and so on. And then we have some enterprise software applications. The largest are SAP, Oracle. There are middleware providers, IBM and Oracle. For data management and storage, we have IBM, Oracle, Microsoft, SQL Server, MS SQL here. Sybase, Hadoop meant for big data, and then the physical storage, VMC squared. And then we have networking operating system, Linux, Unix, hardware provider, Cisco, Juniper, Tricom, and then we have telecommunication services providers. The internet platform, we have this hardware software management services to support. We have web hosting services, we have routers, cabling, and wireless equipment, and then hardware servers. We have IBM, Dell, and then web development tools, suites like Microsoft Visual Suite Studio, Net, Oracle. We also have Google. There is a Google platform today. And then in order to combine all those things, not all companies have all the resources. So we have we have consulting firm. This is the international consulting firm and such system integration companies. And then we have a legacy system, which are the old PBS system created for the mainframe, but too costly to replace and design. So we require them to be integrated. So we will develop, we have middleware to integrate them. So the current trend in computing hardware platform, we move towards more mobile digital platform with the advent of smartphone. We have an iPhone, Android. We have widely used today. We have netbooks, tablet computers, Kindle, e-book readers, and other wearable devices. And then there are also this consumerization of IT and bring your own device, where people bring their devices to office, and then these devices are connected or installed with BYOD applications, so they can use these devices as their computer, as their working equipment in at homes. Yeah, working equipment at homes. Then we have a new method of using quantum computing or quantum physics to represent and operate on data to increase the computing speed, so better processing power. And then there is also technology of virtualization. Technology of virtualization will reduce hardware and powers expenditure. Okay, I'll show you. So for example, we have one server. This is just a single server. physical server. It is a physical server. By virtualization using software-defined storage, we create virtual servers. So you can have three virtual servers. Example, three virtual servers. It can be more, it can be less. So we have virtual server. Virtual server 1. We have virtual server 2. We have virtual server 3. So we have this is called virtualization, where we reduce the power and hardware expenditure because, in fact, there is only one server. Physically, there is only one server, but you can manage the virtual server as if it is separate server. Okay. Okay, any questions so far in terms of virtualization? Okay. Have you used any virtualization, Rizky? Okay, if you go, okay, if you want to subscribe, web hosting, for example, they offer this VPS, virtual private server, or you can have a dedicated server. Dedicated server is quite expensive, but you can have a virtual private server. Virtual private server, you look at it as if you are running your own server, but it is actually a virtually private server. The server is a single server where you share with other clients as well, but they give you virtual private server. It's something like this. You have your own virtual server.
How do this reduce the hardware and power expenditure, Doctor?
Because they only have one hardware. Instead of having 3 hardwares or 4 or 5 or even 10 hardwares, they only have one hardware. So that's how, if you have three, for example, in this diagram, if they actually have 3 servers, so there will be, every server will require their own power. And then of course, cost of the hardware. So this one, they only have one physical server. Okay, so, but of course, the size is smaller. This maybe just about 10 gigabit, 10 gigabyte each, and so on, or 20 gigabyte each, or different sizes. Okay, any question? Okay, and then besides that, we also have our cloud computing today. On cloud computing, we have infrastructure as a service. Okay, this is the cloud computing. We have infrastructure as a service, IaaS. IaaS is just for the CPU, the network, and the data and the storage, data storage. We call it IaaS. And then other software application, we call it SaaS. This is software. We have SaaS. And then we have platform, PBS. And then there are many more, database and server and so on. But this is the basic one that we have today. And then PAS is combination of software and infrastructure. For example, you want to buy a PAS platform for e-commerce. It will come together with some infrastructure, with some database storage, the network, together with the application for electronic commerce, for example, payment gateway, your card, you need to have a card to buy, and then the other catalog systems and so on. So the cloud computing, it is an on-demand computing services obtained over network. So actually, for those who don't know, it is physical. It is physical. It's nothing on the cloud. It's physical on Earth, but it's network over the internet. And then cloud can be a public cloud or private cloud. It allows to minimize the IT investment. Drawback only in terms of security. It's not so much of technical security, but more of regularity. Regulatory because this the regulation or the law allows the government of the country to have access to data that reside within that country. So if, for example, if you subscribe to Amazon and then it is placed in in a foreign country, that foreign country will have access to your data. But in a way, you can also have hybrid cloud computing model where certain sensitive materials you put into your private cloud, and then only those which are open to public you put into the public cloud. Yes, this is an example of Amazon Web Services Cloud. And then there are also trends to move into green computing to reduce energy, more into power reduction. We have data centers which are moving into green computing. We have high performance power saving processor, multi-core processor. We can do multi-threading. And then we are moving towards Linux and open source software. We have Apache web server and so on. And then software for the web, we have today Java, HTML, HTML5. Java virtual machine is more towards portability. Portability meaning that you can, if you program the software say Microsoft platform, yeah, MS-DOS or Windows platform. So it is portable. You can also reuse the same program in a Linux operating system. So that is portability of the Java virtual machine. We have web browsers. Today, people use Chrome, Firefox. IE is closing down shop and then they have replaced it with Edge, I think. And then HTML, HTML5, Ruby and Python are this scripting language. And then we have web services and web service architecture. Web services. Yeah. What time is it today? Now. Okay. Okay. Now 10. Okay. Before I move into web services, I think we'll take a break first, about 20 minutes. Yeah? Oh, 15 minutes. Give it 15 minutes. And we'll come back at 10:15. Yeah. And then we'll move into web services. Okay, we will continue. We move into web services. Okay, what is web services? Web services is a service that being provided by one computer to another computer. Meaning the goal is actually to provide the services to maybe to the customer for your internal services or and then for your vendors. But the services is being delivered from one computer to another computer. So when it refers to web services, it refers to a computer delivering data and resources to another computer. We have what we call a service-oriented architecture. The architecture is to provide service. Yeah. So the term is web services. The common language is extensible markup language. Currently, there are also people using JSON, JavaScript oriented language, JSON. And then SOA stands for Service-Oriented Architecture. It's actually a set of self-contained service that communicate with one another, meaning that one computer communicate with one another computer to create a working software application. So this software developer reuse these services provided by the other computer in combination to assemble another application. To give you an example. So say for example, Southwest Airlines systems, they have their own application system here, and then the application system comprised of several components. And then one of these components actually is about providing a car rental. So they have a platform, a portal. In the portal, they provide many kinds of services. You can book your flight ticket. You can get your meal, for example, what you get from AirAsia today. And then you can also book your hotel. You can also book your car rental. Okay, where do they get their car rental information? They use web services. So the web services, the overall architecture is called web service-oriented architecture. So through these web services, the server will be able to have access to another server here, and then have access to the legacy reservation system. From this legacy reservation system, all the data information relevant to Southwest Airlines can be posted up through the server, through the web service, and then post up here. Similar similar thing goes to tour operator system. It is a car rental system which is uses car from this from this company dollar and the car system, and also travel reservation system and so on. So the data from the web server, data from web server to another to the other is over written in XML. Yeah, so that this data here can transfer to data here using XML. Yeah. So this is service-oriented architecture. Any question? Yeah. So it is not similar like you see hyperlink. It's not just simple hyperlinks. It's actually a proper service-oriented architecture. Yeah. Okay. We move on. Besides that, we also have software outsourcing, cloud services, software packages that you buy. There are also open source software, yeah, enterprise software, and then software outsourcing. You can outsource your software development to other companies. There is also cloud-based software services and tools, SaaS, yeah, where they have their service level agreement. We have mashups and apps. Mashups is combination of several apps to become a single app. You combine several apps, you combine, and so that it's integrated, and you have one mashup. Apps is apps that you have today, applications, and then whether the company want to shrink or grow, it need to be flexible. So we have the term scalability, where it's able to expand to serve larger number of users. For mobile computing, you need to have some certain new policies and procedures to manage this platform, especially pertaining to BYOD, bring on your own device. And then you need to have contractual agreements with firms running clouds, especially in terms of the security and privacy. And then management and governance, we look into who controls the IT infrastructure. Normally it is for database, it is database administrator, we have network administrator, yeah. And then how should IT department be organized, whether it can be centralized or decentralized depending on who make the decisions. If the decision is centralized, then you have to have a centralized IT department. If every business unit have their own IT department, then it is decentralized. And then, but you need to determine whether you want to buy or rent, whether you want to use cloud computing. But the main thing that you need to look at is the total cost of ownership, TCO. The total cost of ownership analyze the both direct and indirect costs relevant to the information system services, information services. So usually hardware and software only account about 20% of the TCO. The rest is 80%, which include installation, training, support, maintenance. All the rest will be 80%. So how to reduce? One option is to use cloud services. But from my own personal account, I personal experience, even if you use cloud services will depend on the type of cloud. Some cloud are quite expensive as well, and then the TCO is not much differ, doesn't much differ compared to you have your own in-premise system. For example, if the cloud services is charged in US dollar or in Swiss franc or in Great Britain pound, the currency exchange rate is actually very high. So, so you reduce in terms of the uh, cost, but when you multiply with the currency exchange rate, so it becomes expensive. So how do we develop the competitive forces for IT infrastructure? So this is the strategy that we can use. The first one, you need to understand the market demand for the customer service, the supplier service, and enterprise service. What is the market demand for your firm's customer service, supplier service, and enterprise service? Then you identify the firm's business strategy, like we begin in our class today. We talk about the business strategy. We need to know the top levels business strategy of the organization, from where it derives the IT strategy, your company's IT strategy, infrastructure, and cost. So these are the internal factors. At the same time, you look into the information technology available outside there, and then you look into the external market factors. External market factors comprise of the competitive firms' IT services and the competitor firms' IT infrastructure investment. And then you determine your firm's IT services and infrastructure. Yeah. Okay, that's all for this topic. We move into the next topic. Next topic, database file. It's for database management system. So before we move this, I want to I want to talk about entity and attribute. You need to clear yourself with have a clear understanding of what entity and attribute first. Stop share. I'll open up whiteboard. Okay, what is the difference between entity and attribute? Okay, who would like to answer? Ritika, what is entity? What is attributes?
No idea.
No idea. Fadli?
Entity exists in the real world.
Okay.
Okay. Attributes that define the characteristic.
Entity is
something that exists in the real world.
In the real world. Okay. Can entity be an abstract?
I think cannot.
Can. Entity can also be an abstract. You can say happy. What does it mean by happy? And then what are the attributes of happy? Happiness. It can be an abstract. And attributes is characteristic of that abstract. Yeah. I'm Diana. Do you have any idea? Do you have any different explanation? What is entity and attributes?
Okay. Entity is like object or something like a form. Attribute more to their characteristic.
Yeah. So we have we have entity. For example, I'll draw something here. This is a man. This is my drawing. Skeletal man. Oh no, wait, this. Oh no. Okay. Okay. Okay, this is the person. So this is a person. This is an entity. It is a concept. Entity is a concept or object. It can be abstract. It can be physical. It can exist in real world or doesn't exist in the real world as long as it is an object. Yeah, a hypothetical object or abstract object, both all can. And then this entity have attributes. Yeah, have attributes. What are the attributes of an entity? For example, if this is a person, the attributes should be their name, name, it can be the address, can be the date of birth, it can be the ID, it can be the height, yeah, it can be the weight, or anything. That is entity. Okay, now how do we put this up entity into data? So we move on to the just to the slide. When you put into data, we have entity here. Entity is person, place, thing, whatever, and then attribute is the characteristic or quality related to the entity. But when we put into data, we have what we call here. We have here record and field. So, and then we have entity here and attribute. So, record relates more to the entity, field relates to the attribute. So you place information about the entity in the record. We have a person record, record on Risky, record on Idiana, record on Fadli, for example. Yeah? And then the characteristic or the attribute is placed in fields. So the larger set, we call it database. Database is group of related files, and then we have files, group of records of the same type, and then we have record. In record, we have field. Field we have in the field are the characteristic, and then this record reflects information on the entity, every information on the entity, and then each of the field is actually the attribute that relates or pertains to the specific entity or record. So we have here, we have database, large database comprised of course, financial file, personal file, and then we have file, we have different students, and then each, we have different records here. Okay, this is one record. This is one record here, and then we have the field. This is a field, and then this is the field. Yeah. Actually, the database ends here, but this is just an additional information. Additional information is that the data comprised of bits and bytes, and then we have 8 bits. Standard is 8 bits is equal to 1 byte. Actually, when you look into your whatever information that when you use relate to database, remember the small b means bit, the capital B means byte. So KB, if it is K, B small is kilobyte, B capital is kilobyte, is small is kilobit. Yeah, bit is just 0, 1, 0, 1. Each of it is called bit. And then when you group 8 of it, it becomes a byte. Okay. So we have a problem with the traditional file environment. Traditional file environment does not refer to the old physical file, it's still electronic file. But these files are maintained separately by different departments. So because it is maintained separately by different departments, we have data redundancy. Yeah, each department will have its own record. For example, for the same customer, say name Ali, so it's kept by the HR, the sales department, it's kept by the marketing department, it's kept by the production department, it's kept by the finance department, same record. But and then so they are like redundancy, but at times it is inconsistent because some is spelled Ali Abu Bakar, for example, and then some is Ali A Bakar. So we have data inconsistency because it refers to the same person but with in different form or different structure and so on. So it cause inconsistency and redundancy relates to inconsistency. And then there is also program data dependence because every system that are being used by each of different department are different. When they use different system, so these different system have different requirements for the data. So the data is dependent on the program. So it is program data dependence. So if you use a different set of systems, when you want to move from one data from one system to another system, which is not flexible, it's not easy to share because the format is different. So we have lack of flexibility, and also because there are too many systems, it is poor security, and then of course there is lack of data sharing and availability. So how do we overcome this? We have silos of data where data are maintained separately. We have data redundancy, we have data inconsistent, we have program data dependence, we have lack of flexibility, we have poor security, we have lack of data sharing and availability. So how do we overcome all these issues? We develop a central database. So this is an example of the one that I explained to you just now. We develop a central database. We call it database management system. The database management system, we have a database that serves many applications by centralizing the data and controlling redundant data. So we call it database management system. It interfaces between application and the physical data file. So it separates the logical and physical views of the data. So in a way, it will solve the problems that we mentioned just now, the controlling the redundancy, eliminating the inconsistency, uncoupling the program and data. We call it loose coupling. And then so that it enables the organization to centrally manage data and data security. Okay. So what is okay, this is an example of centralized database where we have all the human resource data here in the central database, but different units will have access to different systems. So this unit that handles the benefits, this unit that handles the payroll, they only see several different systems. So for example, this is for example name, SSN, and healthcare are only being seen by the certain group, and then the others for the payroll they see name, they see SSN, they see gross pay, and then they see net pay. So every unit or every person have different view on the same data. So this is organized by a central database management system. Okay. So the most common central database management system, the most common today, but we do not know in the future. But the most common database management system today, we call relational database management system. Sometimes we call it RDBMS, Relational Database Management System. So this Relational Database Management System, it represents data in two-dimensional tables. This example is like this. It is two-dimensional tables that has row and columns. Yeah, columns. These are the columns, and then we have rows. Yeah, rows and columns. So each table contains data on the entity and attributes. This is the entity, for example, 8259, the name of supplier CBM Incorporated. This is the entity. And the attributes. Attributes the supplier name, street, city, state. For example, this product is the entity and the attributes, the unit price, and so on. So in the table, we have grid of columns and rows. Rows is the record for different entities, and then fields or columns represent attributes for the entity. So there is two key fields used to uniquely identify each record. We have here, we call it primary key, and then we have here a foreign key. So the primary key is where primary key is unique. Primary key is unique to a unique number to refer to a specific record. For example, the record is for CBM Incorporated. They have a primary key 8259. So there is no 8259 there. Only one 8259, meaning that is the primary key. For example, like us, we have our IC number. That is the primary key. So it is unique for every supplier. Yeah. So, and then when the primary key is placed in another table, this is the table for supplier. When it placed in another table, for example, table for part, the primary key becomes a foreign key because it can be more than two or more than one similar keys in the foreign key because it is no longer unique there. But the uniqueness is at the primary key when it is at the primary key. So when the primary key is placed in a different table, it's called a foreign key. So this primary key and foreign key is being used to refer or to find or to query. The right word is to query, extract information on the data, to extract the data. Yeah. So let's see, for example. So this is the basic relational DBMS, but you don't have to remember that there are many more SQL. This is called SQL, Structured Query Language. So the basic, I showed you. Okay, this is how SQL queries. SQL stands for Structured Query Language. Structured Query Language. Yeah. So from using structured query language, you can select part number. This is part is the table. Part number is the field. Part is the table. Part name is the field. Supplier table. Supplier the number is the field. Supplier table. Supplier name of the field. You want to select this from the tables of part and tables of supplier, where part and supplier name is equal to supplier name and part number 137 or part number 150. When you talk about or, we have here, we have one or. So this we have here A, B, and C. B is equal to, and then we have A or B equals to. What is A and B?
C.
C. A and B is C. Yeah, so A and B is C, and then A and B, A or B is A and B. And also C, of course. Yeah, so C is in the middle. Okay, when you talk about A or B, meaning that it is 137 or 150. This is both A and B. So if you look at the this point here, okay, this is where, so when it the part is or 137 or 150, they want to save yeah, between part and supplier, and then where it is 137 and 150, so they put both. So because it is or, that is how the SQL works, or SQL works. And then this database management system have data definition capabilities that define the data, have data dictionary, have query and reporting tools. We have the structured query language, and then not one DBMS that have report generation capabilities. Example is Microsoft Access. This is Microsoft Access. And then besides that, we have this entity relationship diagram. Here is an example of the relationship diagram, many to one, yeah, in Access. So when you design database, you have this conceptual design versus the physical design. We do normalization. This is how you do normalization when in a single table. This is you will have too many lines, and then it will not be efficient and effective to query and then those. So we break it, normalize it into smaller tables. We have keys. So this is normalization, and then it is built upon using referential integrity and entity relationship diagram. Okay, so this is the referential integrity. We have one to many. Yeah, we have here one. Okay, this is one to many. Yeah, this is one again to many. This is many to one. How do you look at it? You look at the symbol here. So this is one. So one to many. One to many. Many to one. So combining the referential integrity into this entity relationship diagram. This is the entity. Supplier is entity. Part entity. Line item is entity. Order is entity. So we can infer one supplier provides many parts, and then one part is ordered by many line items, and then many line item belongs to one order, or the other way around. One order includes many line items contains one part, and then many part is supplied by one supplier. Okay. Besides the entity, the relational database management system, RDBMS. Besides RDMS, we also have non-relational database. We term it as NoSQL. NoSQL stands for not only SQL. It is a more flexible data model. The data are set across distributed machine. It can be hierarchical, easier to scale. It can handle large volumes of structured and also unstructured data. That is why it is being used for big data, because big data, there are more than 85% of unstructured data. Then there are also database in the cloud, for example, Amazon, SQL Secure, and private clouds. The big challenge of big data, the challenge of big data is it handles a lot of massive data. Most of it is unstructured or semi-structured, 85%. So it requires new tools and technologies. We have Hadoop, yeah, and, and Mongo and so on. So business intelligence and infrastructure. Okay. Okay. Any question before we move into business intelligence infrastructure? Any question on big data? Or any question on RDBMS? Everybody okay? Okay. Database utility. Yeah. Okay. Business intelligence infrastructure. What is business intelligence? Business intelligence comprised of, actually, the business intelligence is an old term, old terminology. Today, people call it business analytics. But what is the difference between business analytics and business intelligence? Historically, when they created, when they coined the term business intelligence, it is meant for descriptive analytics. It is meant to study and to analyze the past data. Yeah, business intelligence, historically, it was meant to analyze past data, the previous data. So when you provide when you analyze previous data, so you can have ratio analysis, you can do variance analysis, you can do a lot of things, but providing the description of the past businesses or the current businesses. So it is called, it is termed as business intelligence. But as time goes by, and then we have data warehouse, we have data mining, and then we move on. Instead of just looking into the past, we look into the future. When we look into the future, we call it predictive, and we coin the term predictive analytics. When we have the term predictive analytics, so the previous record is called descriptive analytics. So then we have, I use my whiteboard. So we have this business intelligence which started with descriptive analytics. Which is meant for the past records. And then we have predictive analytics here. Predictive analytics, we target for the future. We can predict the future using data mining. Using data mining. Yeah. How do we use data mining? We can look into associationship. We can do clustering. We can do sequencing. So after this will happen. After this will happen. So we can estimate the future. We can not estimate. We have what we call uncertainty. The term is uncertainty. So with uncertainty, we can measure what we call probabilities. This is predictive analytics. But once we have predictive analytics, and then we want to say, we want to use this for decision making. We want to make assumptions. Yeah, assumptions. So we have prescriptive analytics. where we start to make assumptions. Yeah, we make assumptions and optimization. So we have this predictive analytics. We have Monte Carlo model and so on. We create assumptions and optimization. So and then we coin the term here, business analytics. So the term business intelligence and business analytics is interchangeable. So if you look from the point of business intelligence, we can say that these are called descriptive analytics. These are called predictive analytics, and then we have prescriptive analytics. Same goes if you look from here this point of view from business analytics. We also call this descriptive analytics, predictive analytics, and prescriptive analytics. It is interchangeable, but we know that business intelligence comes first historically, and then it is developed to handle past records. Okay, move on to the slide again. So in order to handle this prescriptive, predictive, and to have data mining tools, we have this data warehouse. Data warehouse where we store current and historical data from many core transaction, operational transaction systems, and then consolidate them, standardize information to use across enterprise, but the data cannot be altered. So we refer to them as, we call it non-volatile. Non-volatile. Let's see. Dari sini. Are you there?
Yes, Prof. I'm
okay,
here.
what does it mean by non-volatile or data cannot be altered? What does it mean? Okay, let's see. Who actually come from accounting background here? Aisha Ghaffar, what does it mean by data cannot be altered or non-volatile?
Okay, let me try. It means that the previous data is not erased when new data is entered in.
Yes. So how do you deal with it when you make an accounting entry and then the data is erroneously entered, meaning that it's wrong data which was entered? How do you change that, Ritika?
Normally we have to in my company, if we did something wrong with the data or entered incorrectly, we actually seek for approval for alter the data. So
can you alter the data for accounting records?
Normally we cannot, but if it's wrongly key in, we either do some adjustment to make it correct, to make the data correct, or we ask our headquarters to actually change the
Can you change the data? Okay, Said Aiman, how do you change data in accounting records?
Normally, we do a credit or debit note.
Yes, we need to post another entry. We cannot alter the data, yes, Ritika. We cannot alter data. That is illegal. You will end up in jail. You cannot alter data. That's illegal. So what we can do is actually to post another corrective entry, meaning that meaning if you have erroneously debit, you have to credit. You have to do a reversal entry. You have to post another entry and then it will be recorded. So that similar same goes with data in warehouse, in data warehouse. You cannot change the data. Data cannot be altered. It is non-volatile, meaning that if there is any changes, you have to post another entry. You have to post another entry. So the data will be, the changes will be recorded. Yeah. Salwani, any comments, Salwani?
Yeah, doctor. None. None comment from my side.
Okay. So data warehouse will be able to provide analysis and reporting tools. There are many reporting tools depending on the whether it is predictive, descriptive, or prescriptive analytics. So and then besides data warehouse, we also have data mart. Data mart is a subset of this data warehouse because we want to process this data. We cannot be, and because data warehouse are big. Actually, data warehouse physically it is not big. Physically it is not big, but data-wise it is big. In terms of data-wise, it is big, but physically data warehouse is not big. You can develop your own data warehouse and then you place it in your server. Where is the server? The server is in the rack. Where is the rack? Rack is in the data center. If you go to the data center, you can see a big building. So that is called a server farm. You move to a server farm, there are several data center there. You enter one data center, can see hundreds of racks. When you see hundreds of rack, you just go to one of the rack. In the one rack, you have a 2U or 4U server. In the one small 2U server, there are several data warehouse inside it. So physically, the data warehouse is not big, but in terms of data wise, it is big. So data wise is big, and then so you don't want to every time you want to process, you have to process terabytes or exabytes of data. So you develop data marts. Data marts are targeted to specific area or specific scope or specific functional area of the data warehouse. It can be finance, it can be production. So you have a specific data mart. So and then that is that. Besides that, you also have Hadoop. Hadoop is meant for big data to target for non-structured, the unstructured data. So you can do distributed parallel processing to handle the unstructured data. Yeah, they are the key services is HDFS, MapReduce, HBase. So besides that, we have also in-memory computing to use for big data analysis where we run RAM processing, meaning that they don't fetch data from the data secondary storage, but it is run in the RAM. So it would be reduced. So this is a diagram for data warehouse. We have operational data coming from the TPS. Yeah, we talk about TPS, right? Transaction processing system. We have historical data that can come from your MIS. We have machine data that can come from your IoT. Web data that comes from the web. Audio and video data. We have external data, and then all these move into your Hadoop cluster. Some of your operational data can also go to the Hadoop cluster, which is meant for big data analysis. Analytics, and then we have ETL here, extract, transform, and load, put into data warehouse. It can be broken into several data marts. So we have casual users. We have casual users that look into casual queries, reports, and dashboard. And then you also have power users into So you can do queries, reports, online analytical processing, and data mining. This is much more analytics. This is this is for descriptive analytics. You can have a DA, descriptive analytics. For this part, you can use it for this prescriptive analytics and predictive analytics. Predictive analytics, yeah, predictive analytics, and as well as prescriptive analytics, because they use um, analytical processing. Instead of, at this point, we can have also have this what we call it OLTP, online transaction processing, because it comes from the TPS. Okay. There are tools to consolidate, analytical tools that can be used to consolidate and analyze, and provide access to this amount of data, huge amount of data. One is multi-dimensional data analysis or lab. We can have data mining, text mining, and web mining. Yeah. So this is OLAP. We have multi-dimensional data modeling, where data comes in different dimensions. Instead of just 2 dimensions for the table, for the relational database, we have 2 dimensions. This is 3 dimensions, and then you can have multiple or many cubes. We have multiple cubes. You can have many cubes. Yeah. So you can view the data from multiple dimensions. You can look into different aspects, and then it enables rapid online answer to ad hoc query, online analytical processing. OLAP is online analytical processing. Yeah. Besides that, we can have data mining. Data mining will find hidden pattern relationship with data set. We use a predictive analytics. We can infer rules. So we have associations, sequences, classification, clustering, and forecasting. Associations meaning that a group of data are associated to another group of data. We can draw the associationship. And then sequences meaning after the group of data occur, another group of data will also occur by event. After this event, another event will occur. That is sequences. Classification, we have a specific class. This specific class has specific attributes. With that attribute, this data can fit into this, or records can fit into this attribute. When it fit into this attribute, the same attribute, it is called within that class. For example, we learn in school mammals, reptiles, birds, and so on. So it fit into that class. That is classification. Clustering, similar like classification, but there is no class. Yeah, clustering, you group it with similar attributes, but there is no class. There doesn't exist any class yet. So we call clustering. Forecasting, you just forecast after this happen, another thing will happen most of the time. So that is called forecasting. I put, okay. And then besides data mining, we also have text mining and web mining. Text mining, we look into key elements from large unstructured data set. We have sentiment analysis software to do that. The technology that we use is, we call it natural language processing. Yeah, so we have when we have natural languages, I mean the sentences that human do, not the machine language. We extract out, extract out, or remove the stop words. We remove the stop words, and then we do stemming of the keyword, and then so that we can analyze. From this analyze, we can create, there are a lot of tools that we can do from there. One of it is a sentiment analysis. Sentiment analysis measures sentiments that people have or showed in their social media. Yeah. social medias, and then they have the sentiment whether they're positive, negative, or neutral on certain topics. We do this sentiment analysis. Yeah. Sentiment analysis can also relate to web mining. Web mining is we look into pattern in the web, we look into the web content, web structure, and web usage mining. For example, trend analysis, we can use trend analysis. Google, we have Google Trend, for example. Okay, besides that, let's, okay, database in the web. Okay, this is a typical configuration of database in the web. We have a client with web browser, access the internet, and we have, of course, we have DNS server here. We have web server, web application, and then we have database server here, and then to access the database. So many companies use the web to make some internal database available to customer partner. So this is a typical configuration. And then advantages of using web for database access is you can have ease of use of the web browser. Yeah, you can use web browser to access the data. And then we can have web interface so that you don't have to do many changes and inexpensive to do the web interface. Besides that, you also need to have an information policy, set up the rules, procedure for data sharing. You need to have information governance. You need to have data administration. You have DBA. You need to have data governance to deal with policies and procedures for managing usability, integrity of the data, and we have database administration to create and maintain the database. And then data need to be have to be in good quality. So therefore, we have data quality audit and data cleansing. We go detail later. Okay, that is the topic of database management. We move into networking. We'll take a break for 20 minutes. Okay, take a break for 20 minutes. We'll come back and now it's 10. We come at 11:30.
Yeah.
Okay.
Thank you, Doctor.
Okay. Okay, can we continue? Okay, we'll move on to the topic of networking and internet. Today there is convergence. Before that, previously we have different telephone line and different data network line. So today there is convergence between telephone network and computer network into a single digital network. And most of the time, even in your office, you have VoIP instead of the normal PBS telephony. So all your telephony lines also comes through your data network. So in the US, more than 74% of internet users have broadband internet, and then we have wide use now. Today we have broadband wireless. Broadband wireless where voice data communication are taking place over broadband wireless platforms. So what is a computer network? Computer network is any two or more connected computers. Any two more connected computers, we call it a computer network. So we have a client and server computers. We have network interface. We put here network interface card. Yeah? Network interface. We have a connection medium. It can be wireless, wired, satellite. We have a network operating system that runs the network. We have hubs, switches, routers, which are the physical devices that connect all these components. And then beside this, we also have a software-defined networking where functions of these hub switches and routers are being used, being done by or replicated by this software. We call it software-defined networking. So we have here PC, we have switch, another switch, we have router, and then we have other network internet, and then servers. Okay, routers are actually routers are meant to connect two different systems. So, routers. Routers are we can draw a line here. We can draw a line here. So this is system. This is your local area network. This is the internet. So routers are connecting two different systems. Yeah, that is what router means. And then we have switches. Previously we used to have modem, but now today a lot of people just use routers at home. And then so in large companies, we have hundreds of local area networks connected to the firm-wide corporate network. We have various corporate servers, website, corporate intranet, extranet, back-end system, wireless LAN, Wi-Fi network, video conferencing system, telephone network, and wireless cell phones. Yeah. So what is this? What is extranet? What is intranet? Intranet is the network within the organization. Extranet is the network goes beyond outside, beyond external to the external party. So intranet within the organization, extranet goes outside to the external party. So these are intranet and extranet. Yeah, so we have website. In the website we have internet. Internet is the general internet, general, and then we have intranet within the organization. Sometimes your each and different unit have their own intranet, and then extranet is where you cater for your vendor, where you cater for your agent, your sales agent. So they have access to your system. This is called extranet. Yeah. And then this is an example of corporate network infrastructure. We have mobile phone, telephone service provider, internet. Yeah, I think it's very familiar to us. The basic model for this key digital networking technology is the client server computing. Client server computing is a distributed computing model where the clients are linked towards the server through a network, and then it's managed by this network server computer. We have a network server. So with that, we have an auditor. Okay, this is a network server. I'm showing you network server here. There is a network server that manage all the clients. So they link to this network. The network server will set the rules of communication for network, who can connect it to what, and what is the security, how do they log in into the network, and so on. So every client will be provided with an address, so the others can find you in the network, find each other in the network. So, so this address is called, sometimes it's called local IP. Because they cannot provide everyone with his own IP, so they generate a local IP address for internal. So this has replaced the centralized the mainframe computing service. Okay, but with the advent of IPv6, we can do away with the local IP. So we'll discuss about that later. IPv6. Today we are still IPv4 and IPv5. Okay, packet switching. Packet switching. Previously, we have the circuit switch network, and then with the advent of the internet, Prior to the advent of the internet, they created this packet switching network, packet switching model. Packet switching model is actually they slice the digital message into parcels and then pass it along the communication path and reassemble them back. So this is packet switching. We get from this packet switching is where we have this internet where data comes in packets, have a header and tail, and then it can be broken into packets. The packets can pass through different communication paths, and it will be reassembled back at the destination. So such a way it makes it faster for the data to be delivered or transmitted from one end to another end, and then there is a method to ensure that it is able to reassemble all the data together again. So this model, there is a model for this. We call it transmission with protocol for it. We call it transmission control protocol and internet protocol. Transmission control protocol is the monitoring or managing the transmission control from one end to another end. Internet protocol where they have a specific standard for the internet. So the protocol is the rules that govern transmission of information between 2 points. And then the TCP/IP is the common worldwide standard that is the basis for the internet. So Department of Defense US actually created this TCP/IP based on these 4 layers: application layer, transport layer, internet layer, network interface layer. You just know this. You don't need to know detail because you are not taking computer science. So we have this application at the deep end, and then we have transport protocol, internet protocol, and then network interface. So these layers are connected. For example, the internet network interface is connected to computer B. Yeah. This is connected to here through this connection, and then move on. So data comes from here, move here, move here. Once this is connected, so it will be able to move here, and move here. Eventually, the application A is able to share resources to application B using the network interface, internet layer, transport layer, and application layer. That is how connection is being built. Okay, that is the protocol. And then there are 2 types of network signals. We call it digital signal and analog signal. Modem is the one that translates analog to digital, digital to analog, vice versa. And then there are several types of network. We have local area network comprising of internet, client server, peer-to-peer, and then by size. It's actually by size. Not really by technical, but by size. We have wide area network, metropolitan area network, campus area network. This is a modem function where computer transmits digital data, digital signals, pass to the modem. Modem stands for modulator, demodulator. We don't use a lot of modem anymore today. Translate to analog and signals from the analog signals from telephone line, analog converted to digital for the computer usage. Today, a lot of people using wireless, and we also use this Unify, where the signals come in digital. You don't require a modem to modulate and demodulate signals anymore. There are several types of transmission media. I think the most popular is twisted pair wire, Cat5, the network cable. There are two types of net fast. There is RJ11, the full telephony, RJ11 and RJ45, the cable network, which can be UTP5, UTP6, yeah. And then coaxial cable. Coaxial cable is the cable that you use for your telephone, for your television. Yeah, television, the Astro cable, and that is coaxial cable, where you have a core in the middle and strips of wire around it. That is coaxial cable. We have fiber optic cable that you see in your Unify or Maxis fiber. That is fiber optic cable. Then you also have wireless transmission media. We have satellite and telephone and cellular system. Cellular systems comprise of cells. That's why it's called cellular, comprised of cells and satellites. Okay, satellites. I see satellite. There are two types of satellite. Yeah. Okay. Let's see. Satellite. We'll go satellite first. Satellite. We have say we begin with an Earth satellite. Yeah, we have an Earth satellite here. And I have to draw this. Yeah. We have an Earth satellite. Say we have an Earth satellite. How to draw Earth satellite? Okay, I don't draw a satellite. I'm not good at drawing. So we have point here, and then we have a satellite here. Say this is a satellite. How do I draw a satellite? Okay, this is a satellite. My satellite is a box. So you transmit the satellite signal from the Earth to the satellite, and the satellite will pass down to Earth, and then we have another receiving end here. So normally you will see we will use a parabolic dish or maybe a telephone. Yeah. So this is right. This is by reflection, and then they use a radio wave, and then they require what they call a line of sight. That's why when there is cloud or disturbance, the satellite cannot see you, or you cannot see the satellite. Require line of sight. Yeah. Okay. And then there are two forms of satellite. One we call it geo satellite. Geosynchronous satellite, and then the other one is low Earth orbit satellite. So normally this is abbreviated as GEO. This is abbreviated as LEO. Yeah. When you say LEO satellite, it means low Earth orbit. When you say geo satellite, it means geosynchronous satellite. When you talk about geosynchronous satellite, it is fixed at a specific coordinate, meaning that it is a free fall position. When it is a free fall position fixed at the specific coordinate, so it maintains at the specific coordinate. So it free fall together with Earth. It moves with the speed of the Earth. With the speed of the Earth's rotation, it moves with the speed. So it's the same coordinate all the time. So for example, Miasat, Suraya, yeah. So these are geosynchronous satellite. But you also have low Earth orbit satellite. For example, like I'm not sure with Inmarsat, or maybe Iridium. You know, Iridium is a low Earth orbit satellite. They have about 48 satellites. So they are lower, and they are more faster. So they can they can cover rotate one round in about 2 hours or less than that, so that they have many satellites, so it can cover. So, but there is a drop call. There is a drop call because this happens when you move from they move from one satellite to another satellite. So when you are connected to that satellite A, for example, and then when satellite A pass, you have to move to satellite B. So at times there are drop calls. So this satellite, there are two types of satellite. We have what we call it point to point, And then we have also point to multi-point. Yeah, to multi-point. Point to multi-point. Yeah, point-to-point satellite. Example of point-to-point satellite are like Suraya. Yeah, we have Iridium. We have Asia Cellular Satellite. We have Inmarsat, International Maritime Satellite. Yeah. Point to multi-point satellite. Example, we have Miasat. We have Palapa. We have Pyongsat. We have Razaksat. The most common that we heard today is a point to multi-point. Point to multi-point satellite are broadcasting satellite. So when it's broadcast, everybody have the same signal. It is the decoder that determines who gets what. But point-to-point satellite is like a telephone. So it has a number, you call the number, the person will receive that call. It's two-way, it's point-to-point communication. Okay, that is satellite. So, but satellite also have this, previously we have, for example, at Suraya have their XBSL, digital subscriber line, they have a digital subscriber line, XBSL. No, because they do it point to point. To point. Okay. This is the satellite communication, and then for cellular communication, cellular system, it comprise of cells. Let's see. Let me again. It comprise of cells. Yeah, we have cells. Cells normally cells are connected with each other. At times it's also separated from each other. For example, you can move from Kajang here. You can move to Sedang. It is called radio base station, RBS. Radio base station. So you can move from, say you're driving, you're using, this is a cell. This is a cell. This is another cell. That's why it's called cellular. So you move from cell to cell. So when you use the phone, you are here, for example. Yeah, you are here. So within this you will be using this specific radio base station. But if you move to another place, you will be using the radio base station here. But when you pass through, you'll be connected between these two radio base stations. But say you go to another, say here is Sepang. For example, that is just an example. Sepang. Moving to Sepang, for example, and then you will be traveling here. So there is no coverage. If you talking over the phone, you will have a drop call until you get connected again when you pass into when you are within a specific coverage of the radio base station. So when people are talking about the 3G, 4G, 5G, when you move into 5G, the coverage area gets smaller and smaller. Yeah, but it is not meant for normal telephony. Actually, this 5G is meant for broadband telephony, broadband communication. So transmission speed is calculated by by bits per second, or we call it hertz. Yeah, and then we have a bandwidth. Okay, any questions so far? Twisted pair, everybody understand what is a twisted pair, coaxial. I think you have seen twisted with this coaxial cable at the back of your television sets. Fiber optic cables you have used to it, and then satellite you have used Astro at least for point to multi-point. Point to point, some of you might have used Iridium when you travel to North Pole or South Pole. They don't have cellular system, so you need to use satellite Iridium, or on the ship they use Inmarsat, International Maritime Satellite. Cellular system, everybody is used to cellular system. And then the internet is the world's most extensive network. It's always in capital. Internet is capital I. Why is internet is in capital I? Rizky, why is internet is capital I?
It's because there's only one internet, I guess, Prof.
Okay, it is only one internet.
Yeah.
It is a specific name. Similar like our name, Ahmad A must be capital I, cannot be small because it's a specific name. Internet is a specific name. A lot, I see some people write internet as small, strong actually. Internet, the internet, it is only one internet. It is a specific name. Earlier it was called differently. I covered that in the different course. It was called differently, but later on it is renamed as internet. The internet. Earlier it was called. Earlier it was ARPANET, and then it was ARPANET was decommissioned, and then give rise to internet. Yeah. Earlier it was known as ARPANET. Anybody recall? Advanced Research Project Agency. ARPA stands for Advanced Research Projects Agency. It is under Department of Defense US, and then it is network ARPANET. ARPANET later become Internet. So Internet is I, capital I. Internet. It was. Yeah. So it's the same. It's a change of name actually. It's the same thing. Okay, so it is the world's most extensive network. They comprise of internet service provider that provide the connection. There are many connections. We have T1, T3, we have satellite communication, and then we have cable internet communication. We have digital subscriber line. The most common we have here in Malaysia for quite some time is ADSL, asynchronous digital subscriber line. Also, we have SDSL, synchronous digital subscriber line, commonly known as Remix. ADSL is for home, and then for enterprise they provide SDSL. And then now we have to move into fiber network, which is unified. And then we have dial-up some time ago. We have modem. I started using computer using dial-up 33.6. And then we have 56.6, and then now we move into ADSL, and then now everybody move into wireless, 5G, 4G, and so on. So this is how we connect ourselves to the internet. So and then internet have this internet addressing. Internet addressing, we begin with 32-bit number. This is 32-bit. And then a domain name system that converts these IP addresses into domain names. And then the domain names are in hierarchical structure, and then they have these top level domains. Why? How does it become 32-bit? Because there are 4 of these. So each one of these is 8-bit. Each one of these is 8-bit. So we have 8, we have 8, 8 times 4 is 32. So we have 8 bits. Remember, one byte is 8 bits. So 01010101. So then it can begin with 0 and with 1 to 8. So you add 1 to 8 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 plus 0. You have 255 maximum. So we have 255. So the maximum we can go up only 255.255.255.255. That is the maximum we can go. Because of that, there is limitation for this IP version 4. Yeah. So then we will then create the comes to the advent of the IP version 6, IPv6. Okay, that is as far as you need to know. You don't have to know in detail for this course, but you need to know that these IP addresses are converted into domain names. This domain names is in hierarchical structure, and then we begin with the top level domain. So this is the domain name. We have the internet root domain, which is dot, and then this is we have .edu, .com, .gov, and then we also have here .my. Yeah. .my is a top level domain. The second level domain will be .com, .my. Yeah. .com, .my. Yeah. And then we have the third level domain, which is the host. Yeah. So this is how internet domain is hierarchical. And then there is governance that govern the internet architecture. So we have internet advisory board. We have ICANN. ICANN is the registrar. ICANN is the registrar for the domain name. Registrar for domain name, and then W3C will maintain the standard for the World Wide Web. So you can visit it at w3c.org. Okay, this is a simple basic internet network architecture. We have a backbone, maybe T1, T3, connected to the regional hubs. We have a regional host. This is New York University. Yeah, and then you can have a local ISP, internet service provider. We have client IP address, and then connected to this. We have this POP3 mail and SMTP mail. Okay, so POP3 stands for Post Office Protocol. Against the other mail that we are used to do, we are used to have is SMTP. Protocol. Simple mail transfer protocol. What is the difference between SMTP and this POP mail? Anybody ever used POP mail? Everybody, all of you are only using SMTP. Anybody who have ever used POP? Risky, you have ever used POP mail?
No, Prof.
No. Anybody? Alan Fan?
Yeah, I think my company name is PopMail.
PopMail. Okay, PopMail. What is the difference between PopMail and SMTP mail?
No idea.
No idea. Okay, PopMail, when you pick up the mail in the box, okay, this is post office protocol. And when you take your mail from the box, are your mail still there?
POP3, POP3 no. Oh, now I remember SMTP, the mail will still remain, isn't it?
Yeah, SMTP. When you pick up your mail from Gmail, are your mail still in the Gmail?
Yes.
Yes. When you pick up mail from your post office, are the mail still there?
No.
No. So SMTP is post office protocol. When you pick up your mail, the mail should not be there anymore. So once you have read, so you put it up into your computer. So the mail is in your computer. But if you go to the post office, there is no mail. So you don't have to. There is no because why do they have this POP mail before? Because they want to limit the storage space. Storage space. You know the server. Even now, I think those who have used, I have received I've started to receive message from my Gmail because I've reached the maximum threshold of my data in my Gmail, so I have to clean it up. I have to pick some mails to be deleted and so on because they have reached that. Because simple mail transfer protocol, they do not remove the mail from the server. So the mail will still be there. So it will accumulate. Eventually, even though Gmail is quite big storage space, but you will eventually reach to the limit where you have exceeded your space. But post office protocol, you will not face that because once you pick up, like I learned, because your company doesn't want to keep too much space, of course, yeah. Nobody want to keep so much space to everybody. So once you take email, so it's no longer there. So they can fit it up with another email address. Okay, that is the difference between pop mail and SMTP mail. And then we have this IPv6 instead of the numbers to maximum to 255.255.255.255. We have combination of alphabets and numerical. We have to 8 until sec, and then we have 0 to 9 in combination, and then they have 1 to 8 bits. Instead of 32, they have 1 to 8 bits. Yeah, so, and then there is new Internet 2, which is still being developed. I'm not sure what is the stage now among the universities and with certain organizations in the US. Some internet services that have been common to us are email, chatting, instant messaging, newsgroup, telnet, file transfer protocol, World Wide Web, and then we also have the IP, voice over internet protocol, using IP and packet switching. Yeah, so this is the standard client server computing on the network. We have web browser, client software, internet connected to the server. We have HTTP server. Most, I think we have Microsoft Web Server, and also I think I used to do to have I usually run Apache server. If those who are familiar with Apache server, we have domain name server, utility, FTP, network news transfer, yeah. And then we have application server, database server, and then we have backend systems, database, and then the specific application for different departments. Then we have a unified communication that integrates voice, data, email, and conferencing in the system. And then you also have virtual private network, which is a secure point-to-point protocol tunneling. This is how VoIP works, where VoIP runs using what we call reborn voice. Because those who are used to the old telephony actually they carry your voice over the analog signal and then pass it over to your computer to the other end, same analog signal. But for VoIP or even today's digital phone, it is a reborn voice, meaning that they take your signal, your analog signal, convert it into digital, transmit the digital signal. At the other end, they recreate your voice. They recreate your voice. We call it reborn voice. Sometimes it's better clarity. Yeah, sometimes at times it's better, it's more clearer than the digitally because it's more crispy, clear rather than the normal the old analog voice. But and then this is the view virtual private network tunneling where other people will not be will not be able to have access to your network. Yeah, so you have limited network members. And then the web, we have different hypertext. Most common is hypertext markup language, the one that you see on the web. And then we have hypertext transfer protocol that is used over the TCP/IP to transmit data. And then we have uniform resource locator, which is the address using the domain address and its hierarchy to provide the exact location of the content in your web and the web server and software for locating and managing the web pages. How do you search the web? We have search engine, we have mobile search, semantic search, social search, visual search. Okay, search engine. Okay, one question. Wait, I think I stop here. You'll just discuss because we are going quite far compared to the Monday class. Because I'm quite fast in your class. Okay, on search engine. Does the search engine search the web? Does the search engine search the web? What does the search engine actually search? Does the search engine search the web? Okay, let's see. Zaidatul, does the search engine search the web? It's a search engine, of course, but does it search the web?
I'm not sure. I think it's not searching the web.
Then what does it search?
I'm not sure, Doctor.
Okay, let's go to the other person. Alan Fan, does the search engine search the web?
I think the search engine search the keyword.
Search the keyword from where?
From the, like my company, got many sub pages, like www.asianfrb.com. And for the sub pages like products, under my products, I got my specific products. For example, the cable ladder. Then the cable ladder is the keyword, the search engine search.
So it search the web. It actually search the web. The web pages.
The keywords, then it will have a list of keywords results on the Google, for example. Let's say we search cable ladder, then it will have many companies come out or many web page come out with the keywords. So that
they search the keyword. From where they search the keyword?
The first search the keywords mainly from the HTTP one.
Yeah, is it the web?
That one, is it considered the web?
Yes, that is the web.
Yeah, the keywords of the web one. Let's say in this case, I'm not sure correct or not.
Okay. Okay, Lam Yu Hong. Does the internet search does the search engine search the web?
I think it's the same with Mr. Alan Fan.
Okay, Pritika. Does the search engine search the web?
I think so.
Okay. Rizky, the search engine search the web or not?
Yeah.
I think it searches the keywords.
From where?
From where?
From the web.
From the web. Okay. Hi, Diana, they search the web or not?
Okay.
Siapa sini orang IT ya? IT
on my degree, I think.
Okay, search the web or not?
So search engine doesn't search the entire web, but search engine find web page from the keywords, I think.
How do you get from the keyword?
You have to typing.
Yes, and then what does it do after you have typed?
I don't know.
Okay.
It ranks the keywords.
And then?
It ranks the website that it searches based on the rank of the keywords.
Okay, actually the search engine does not search the web.
Search the web, search query ke, Doctor?
No, the search engine does not search the web. What Salwani, what were you saying?
Did they search the web search query?
Yes, the search query. You put in the web in the search query. You put the keyword in the search query, and then what does the search engine do after that?
They will search it in accordingly lah.
Where?
In the, I mean in the World Wide Web.
No.
No.
No. Okay, what does the search engine do? The search engine search and index. They search and index. Search engine search and index. I'll show you this. Okay, this is what I do. I develop search engine previously. I used to develop search engine previously. I have a, okay, it search the index. Yeah, you're going. So we have an index server. There is an index server. We call it index server. The system is called search and retrieval system. Yeah, search and retrieval system. You can read any books on search and retrieval system. We call it search and retrieval system, or we call information retrieval system. Information retrieval system. Yeah? Or same thing. Yeah? Search and retrieval system, information retrieval system. So when you key in your, say you have a query here. You have a query. From the query, it will search. They will have a search engine. This is the search engine. There is a query engine, search engine. And then search engine will search the web. Not the search the web. It search the index. And they will provide, index will provide, and then they will give you the output to the customer. There is the output. Output, there will be a list. Output will be a list of the link that you see in your browser. Okay. Then the next question: who built the index? Who builds the index?
Is it the web page designer?
Web-based designer. Okay. There are two different systems. Yeah? For the old system, which is Google, for example, Alta Vista or Yahoo, they develop metadata. From the metadata, they create the index. Yeah, for Yahoo, from the metadata you key in, when you design your web, you create the web and then you register it into Yahoo, and then from the metadata, they create the index. The search engine will search the index that is being created. Okay, that is. For Google, differently. Google, they have this, what they call it, they have a crawler. Okay, this page rank algorithm is here. Yeah? Page rank algorithm, if you want to ask how do they do the ranking, page rank algorithm is at the search engine. Page is capital Page because it's the name of the person. Yeah, page rank algorithm is at this algorithm. It is at the search engine. The index is just an index. Even you can subscribe this index actually if you want to build the search engine, you can subscribe the index from Google. They charge you a fee. And then there is another system for the current technology is we have a system we call it crawler. Sometimes we call it spider. Anybody heard of spider or crawler? It is a robot. Okay, it is a robot. Robot doesn't mean it has to be physical. It can be software as well. And then they have this tag. The metadata is called robots.text. That's why when you put some form, they will ask you, "Are you a robot? Are you a robot?" No, I am a robot. So many people face that when they want to register for their AstraZeneca. People ask you, Are you a robot? Are you a robot? Many times you believe, oh, I am a robot actually. So this is a robot. This robot will move from web page to web page. That's what it does actually. This robot moves to one web page to web page. So it move from this page, and then they take this information, they put into their, they have a raw repository, and then they go to the next page. As long as there is no problem, there is no what do you call it, firewall allow them to go in, because they have this identifier. Robot the text is a text file, identify who they are. Then they move in, they put this, and then from this, uh, we have an indexing system. So there is a term called freshness here. Meaning freshness is how often do they, it's like bread, how often do they refresh their index. When you talk about search engine is just here. This is crawler. Yeah. Okay. There is a robot that could do that. Okay, so when you look at we look at our okay, we look back at our screen. Okay. Okay, this is how Google works. The user enters the query. Google web server will receive millions of requests, and then they send to the index server. This is the index server. This is the index server. Describe which page, and then this, they use the page rank algorithm, the index server. The search engine will use this software to provide the result. And then the result will comprise of a URL and a hyperlink. When you click over the hyperlink, you will send you to the particular site. So where do this, so how do they build this index? The index is built by web crawler. It doesn't search the web actually. It search the index. So technology for information retrieval or search engine is about ranking. But the index, how do they build the index? Maybe you can, those who are keen, you can try a few. I'm familiar with this search, with this crawler. Eurythmics. You can try, or you can find several crawler. Crawler, you can just there are open source crawler. You can just crawl, and then but they will fill up your server. Or if you are using desktop, they will fill up your desktop. If you're filling your laptop, they will fill up your laptop. You bring everything in. Once they bring everything in, and then you need to index them. Otherwise, you will have everything in your, all information in your computer. Any question? Okay. Risky, okay, Risky? Okay. So we don't actually, the search engine actually doesn't search the web. Salwani, okay?
Okay, doctor.
Okay. Pritika? Okay, Ellen fine, okay, eh? Ellen fine, it's clear now?
Okay, okay.
Okay, eh? Okay. So, go back to previous slide. So when you search information, same goes to mobile search. They still search the index. Mobile search, And then the semantic search, same goes, but at the search engine, actually it's the same index, but at the search engine they have natural language processing, they have ontology tools, they call it semantic entailment. They call it semantic entailment, so that they are able to search it based on the semantic. Yeah. Semantic, what does it mean by semantic? But do you understand what it does mean by semantic? Okay, it is now about 12:20. So I'll end up here, semantic. I'll just discuss about semantic. Okay, just discuss about semantic for a while. Okay, semantic is the study is called semiotic. Yeah, the study is called semiotic. At the bottom we have syntax. What is syntactic? Syntactic is the rule of the language. Syntactic, and then we have semantic. And then we have pragmatic. This is the rule of language. Meaning that, how does it mean by rule by language? It means like your grammar, the word, syntax. The other words we call it syntax. Syntax, the rule. But when you move into semantic, we call about meaning. There are some meaning. So, for example, there are rule of language that have multiple meaning. For example, when your boss calls you and say, Alan, please bring me the table. What do you bring, Alan?
Table.
Alan, please bring me the table.
Bring him the table.
Which table? The big table, furniture, or the small table, or the?
Depends what he wants.
So how do you determine what he wants?
How to determine what he wants? Understand.
Okay, that is what we call by semantic. Meaning that certain words have multiple meanings. Semantically, they are different. So when we talk about a semantic search, we are looking at different meaning, meaning that same word by keyword. That's why that is the difference between keyword search and semantic search. Keyword search, they search at the syntax level. This is keyword. Semantic search is not by the keyword, it is by the meaning. Meaning that two different words can have multiple meaning. Yeah. So if you look into the thesaurus, not dictionary thesaurus, you can have different meanings. That's meaning. Okay, pragmatic is another word that we have, another concept where there is context, time, and space. Not just meaning. Meaning that the meaning is the understanding is to have the context, time, and space. For example, the same meaning when put at a different time, put at different space, different location. The space means location. And different context, it has different meaning. For example, for us Muslims, we have exegesis. What is exegesis? Shalwani, what is exegesis?
No idea, doctor.
Okay, the word in Arabic we call tafsir. Yeah, then we have tafsir. Tafsir is made based on context, time, and space, meaning that today we cannot have the same semantic. Even we have this is the third level: syntax, syntactic, semantic, and pragmatic. So the study is called semiotic. Semiotic is under subject under knowledge management. So when you talk about exegesis of tafsir, you need to have context, time, and space because it has to be pragmatic. This is semantic. This is syntactic. Okay. This is what we. Okay. Any question? Okay. So we have here. Okay. So we go back to our PowerPoint slide. So we have semantic search here. So for we have semantic search is looking compared to the normal search engine that looking at keywords. Semantic search have search at the semantic level, not at the syntax level. It is at the semantic level, but they have the same index. You see, they have the same index. Index just what index does is just they just scroll and bring everything in, bring everything in. That is it, and then they organize it, become an index, and then search engine will organize, will find, will extract from the index, and then you have social search. Social search is okay. This social search is a little bit different because sometimes the thing that the search engine does crawl into is not crawl because there is another set of crawler that crawl into social network. There is another set of crawler that crawl under the social web. Sometimes people call it differentiate in between white web and the dark web, the black web, the white web, the dark web. The dark web is those sites that are not crawled by the normal crawler. The normal crawler, they crawl into the normal site. But there are specific sites, for example, Twitter or Instagram or Facebook. They doesn't allow crawler to come in. They have their own crawler within them. Their crawler, they will index their content, and then you need a specific crawler that paid or subscribe to this Twitter and so on. They can extract this out, and then we have the social search. In social search, we also have semantic, what you call it, sentiment analytics. We also have sentiment analytics, and besides that, we have visual search and visual web tagging. Pinterest that do they have artificial neural network so that they have this. They can do image recognition and image recognition. Yeah, and then searching the web, we also have this shopping board, search engine marketing, search engine optimization, and search engine algorithm. I mean, mentioned to you just now, page rank algorithm is one of those. Search engine optimization is how do you link to your the search engine with the content, how do you build the content so the search engine can find them, and then combination of search engine optimization and different other tools. We have search engine marketing, and then you have intelligent shopping bots that crawl. It's still a robot, crawl into certain site. This is how Google works. Okay, we will not move into Web 2.0 later. Maybe we'll cover this next week. Okay. Any question? Azim, okay, Azim?
Okay, Doctor.
Okay. Nur Faiza?
Yeah, I'm good.
Okay, anybody not clear? Aisyah?
I'm okay.
Okay, Said Aiman, okay? Nur Aiman, ada dua Aiman Nur Aiman, okay? Any question? Tak ada. Fatin, okay, Fatin?
Okay, Doctor.
Okay, Natasha?
Okay.
Okay. Kalau keluar dalam exam tenanglah ya, dah tahu.
Doctor, I want to ask you something.
Okay.
About the post office protocol. If I'm not mistaken, I remember that my previous company, we received 2 mails. I mean, I received 2 mails, office mail. One is direct from my mobile, and one is in my laptop. So if let's say I did read it in my mobile, so then when I open my laptop, I can't see the message.
Okay.
So
Okay.
Can we call it post office protocol?
Okay. Dia post office protocol ni because when you send, because tak different, itu different.
Different.
Because when post office protocol ni when people send email to you, when people send email to you, your email address, your email server ni, whether they use what sort of protocol does your email server use? Your email server. You can only have one email server. For those many of us actually subscribe to Google Mail. Although nama tu depan Putra BS, at the back end it is Google, it's the Gmail, ya. Jadi it is SMTP server. SMTP server meaning that they follow the protocol which is SMTP. But there are also companies, for example, like Alan Pan, dia kata his company uses post office protocol, meaning that the email that you send to him will go directly to that server, and then his server is a post office protocol. And then this post office protocol, similar like SMTP, can do redirect. Can do redirect. It can redirect to your your mobile phone. When it redirect, and then there is a column, actually a button that you can the server, you can click at the server where you redirect. You still want it to be there, or you want to kalau the standard is once you redirect they remove. The standard is the default, so you will receive it at your phone. Tapi at your phone you have to install the POP protocol juga.
Okay.
Yeah, because a lot of us actually, many of us are using Gmail. Gmail is SMTP. Even my Putra Business School email is running on Gmail.
Microsoft, Doctor?
Microsoft
Outlook is
POP.
POP, right? Because we use the Microsoft Outlook. So when we open it in my mobile phone, so I can read the email that's sent to me that I have already read in my phone at my laptop, and I open it.
Microsoft, because my first email was I pakai nama dia dulu. Masa tu I pakai Hotmail. Masa at that time TMNet, if you can those can recall, TMNet ties up with Microsoft Outlook. So we fetch the Microsoft Outlook, and so it is post office protocol. It was masuk, and then streaming is the same. Bila dia move into streaming still pakai Hotmail. And then recently they don't have any mail anymore. TM doesn't have any mail they provide to the customer.
Okay, thank you, Doctor.
Okay, any other question? Mirza, okay, Mirza? Okay, if there is nothing, now is about 12:35, we are early by 10 minutes. So we can adjourn for today until we'll meet again next week. Next week, I think next week we have class then. Okay. Okay, thanks, bye. Assalamualaikum.
Thank you, Doctor. Assalamualaikum.
Thank you, Doctor. Assalamualaikum.
Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Thank you.